Welcome for today's webinar, where we are going to talk about standardized 5G New Radio for non-terrestrial network. My name is Thorleif Halland, and I'm spearheading the business development here at Gatehouse Satcom with a focus on 5G for non-terrestrial network. But before we dive into today's session, I would like to introduce my colleague Sven. Sven, would you like to say a couple of words about yourself?
My name is Sven Sørensen. I'm heading our product management, and I have a long background from development of mobile phones in 2D, 3D, 4D, which I'm now applying in NTN.
Thank you, Sven. Just a couple of words about Gatehouse Satcom and who we are. Well, for years, we have been developing software, embedded software, communication protocols, waveform and test tools for terminals, satellite and network infrastructure. We are actively contributing to the new 5G NTN standard under the 3GPP. We are just about 45 employees and part of Gatehouse Group, which was founded in 1992. For years, we have incorporating across the satellite industry with a lot of established players and a lot of the newcomers. And here are just some of the names. Here at Gatehouse Satcom, we are focusing on 3 product groups. The first one is DAME, which is a protocol stack for the defense industry. And for years, we have been offering several beacon products ranging from embedded software to different test tools. For the last 5 years or so, we have been developing service within the 5G universe, and our first product is a NB-IoT product based on the 3GPP requirements for 5G. And lately, we have turned our attention to 5G New Radio, which is the topic of today's webinar. So, let's get back into the topic of today's webinar. The mobile communication industry are looking for the next revolution in connectivity. All eyes are fixed on the goal of providing seamlessly coverage everywhere on the planet. Much has been said about New Radio and 5G for non-terrestrial networks, but often in conflicting terms. This tends to muddy the water and causes a lot of conflicts and different opinions on a subject. It makes it hard to understand what are 5G New Radio actually, how does it work, how will it affect the mobile industry, and how will it affect you and me. In this webinar, we'll try and give you a better understanding of the technical requirements for 5G New Radio. We will also address some of the use cases that we strongly believe in. And we will finish off by addressing the progress and the next step of standardization. So Sven, based on your experience, what requirements do you foresee? What are the technical concerns? And what do we have to prepare for?
Yeah, thank you, Thorleif. NTN services is a little bit of an interesting topic, because what we're trying to achieve is that we are trying to use the existing service link of a satellite as the UU interface for a mobile phone or a mobile device, which means that we have to adapt the standards of 3GPP New Radio to also accommodate and make sure that it will work together because it has to be the same device. Satellite communication has a long latency compared to what we know from terrestrial coverage. Means that all the protocol timers, all the details of that will be challenged, which has to be modified. There's a substantial Doppler in case of non-geostationary satellites, which also needs to be compensated for by the system, by the standards. Finally, the signal has to travel a long way, so there's a substantial path loss as well, which will challenge the link budget between the device and the satellite. And finally, there will be a varying beam size from the different satellite systems which are there, which also has to be handled, accommodated by the standards. The major blocks, namely the radio access network and the core network, they are still there. And we expect the way that it will be integrated is via the roaming interface, which has already been defined. There are two modes of operation: transparent mode, where the satellite operates as a mirror, so signals sent up will be mirrored and sent down again. Means that we can reuse the existing architecture of the satellite industry, the satellite communication. I wouldn't say small investment, but at least the minimum investment. The other one is regenerative mode, where there's processing on the satellite, meaning that some of the RAN functionality can be placed in the satellite. This has the benefit that it can enable faster connectivity setup and aggregate the data on the feeder link.
So now just a question is both transparent and regenerative mode, is that 3GPP approved for now, or is it just one of them?
For the current release, which is release 17, transparent mode has been incorporated. It will be improved in release 18, coming in 24. And we will not see regenerative mode until release 19, which is expected. And expected, I mean, so it's not confirmed yet, to be available in 26. So we are all looking forward to sort of being able to mix all the balls. That will be really fun times.
Okay, thank you for clarifying that.
Then it wouldn't work if we don't have users. And what is it that is appealing to users? True global coverage on one device. That's quite simple. And you only need to pay one bill, so only one subscription. You don't want to interfere at all with all this roaming, so it has to be seamless between TN and NTN. And there are some issues related to this link budget, meaning that for some cases you would need to bring your own modem, so a separate device acting as a modem. What kind of evolution do we see? There has been a lot of work ongoing on breaking up the complete system, like radio access network and core network, into different components that can all be mixed. From having only the radio unit on the satellite to having both radio access network and core network components on the satellite. These are all valid and have their benefits. I will also need to say that there is one thing where we need a lot of evolution, and that's on spectrum sharing. We don't think that it's possible to have the same frequency applied in the same geographical area from both terrestrial and non-terrestrial operators. So there's a conflict there. We have national regulations handling the spectrum allowances for their area, but satellite operators need global spectrum, so there's a potential conflict there. There's something about small beams versus large beams, and the capability of continuously modifying and changing the frequency spectrum of the satellites. There are two bands which are in play for release 17. It's so-called FR1. That's the most scattered band as well. It's best suited for device-to-device communication. FR2 which is the Ka band, are more free for new services, and unfortunately it's best suited for this modem type of systems or VSAT systems. And finally, I would like to touch upon what is it that can be used for. So the everyday usage like browsing, social media and so on is occupying in the range of 3 megabit per second. You can do video conferencing at 1.2 megabit per second, and finally mails can go low down as 1 megabit per second. And what can be achieved? That again comes back to the link budget. So if we have asked our engineering guys to help us do a rough calculation on, I wouldn't say unrealistic scenarios, definitely not, but not the worst type either. So with that, we can have 45 megabit per second downlink and 1 uplink. So can fit in to use an ordinary smartphone for at least some services.
Super interesting, and thank you for the introduction. We'll get back to you in just 2 seconds, because I think I mentioned it just before that there are several good reasons why the terrestrial and the non-terrestrial networks are beginning to talk together about combining this into one unified 5G experience. So let's take a look at some of the use cases that you and I believe in. There are 3 good reasons why the terrestrial and the non-terrestrial networks are starting to talk together. The first one is what we call affordable broadband everywhere for everyone. In our country, Denmark, we are so blessed to more or less have access to high-speed broadband everywhere. But in many other countries, that's not the case. We have to remember that only 30% of the globe's surface is covered by a terrestrial network. And today there's less than 100 million broadband users getting their broadband via some kind of non-terrestrial network. And connectivity here includes, like you mentioned before, the dish devices that you can get internet in your home. But the potential addressable market for all kinds of broadband via a non-terrestrial network is estimated to be somewhere around 500 to 800 million users, which is a huge potential revenue upside. The second use case that we believe in, and you also addressed it before, is mobile connectivity everywhere, anytime. 5G has been in focus for terrestrial networks for some years now, and we have more than 230 networks with 5G technology implemented. And we have 1.5 billion users on the 5G networks. But 4G is still the dominant network, but we will see that change within the next 5 to 6 years, where the shift will be into 5G as the dominant network. We believe, and you also mentioned it before, that in the near future, we'll be able to use our regular smartphone across the 2 networks seamlessly. It might not be the same experience on both networks, but that's also okay for now. The third thing that we believe in is this resilient, critical communication infrastructure via a non-terrestrial network. In the digitized world that we're living in today, there's no room for some situations without connectivity. And it's no longer an option just to rely on the terrestrial network, as recent events has shown us. Europe is already starting this journey towards a critical infrastructure for terrestrial networks, non-terrestrial networks, with a project IRIS-Web. And this project might just be the first project delivering 5G New Radio on a non-terrestrial network. But Sven, let's take a look at some of the challenges and how to solve them.
Thanks for the brilliant presentation of use cases. That's really what drives everything. Coming back to what are the challenges that we are looking into. And we already have talked a little bit about standardization. And trust me, we'll come back to it again, because that's really the key. The existing satellite communication is for the few. And we do see a strong push for having connectivity for all and everywhere. We have talked about the releases of 3GPP. I would, however, say that there has been a lot of work ongoing on research projects at universities, funded by ESA, funded by GSOA, funded by 3GPP, all to make sure that this is a viable option, but also knowing where the bottlenecks are. And the latest assembly at 3GPP, there was a dramatic change in the request. So now we see the terrestrial operators also being active in pursuing NTN services. So they are really backing up on this, which is a very good opportunity, a very good sign for all of us. So what are the new requirements that we see there? The existing satellite communication has been constrained by these large dish antennas. It has been proprietary systems. You could not shift your device or your terminal to a different system. You are constrained by having to have a line of sight between your terminal and the satellite. And finally, there is also an issue with power. We have seen a lot of evolution over the last 2, 3, 4, 5 years on antenna technology, and I don't think we have seen the last of that. So hopefully this will solve a lot of the issues. We also see now a lot of progress on the standardization and also an interest from all involved parties to join forces. I don't think that we will be able to provide indoor coverage anytime near, but we can help the other ways. And finally, the users, I also have to come back to them. There is an adaptation needed there. And if we succeed in making this adaptation real, there is a huge market out there.
So maybe you could explain to me what you mean by the user adaptation. Are we going to teach the users, or this is this new?
There's two aspects of that.
Yeah.
One, the user has to be taught how to use a device which is satellite compatible. The other thing is that we need to make the technology easy to use.
Because I'm used to just taking my phone to the ear and then just talk it in, and then that might just be a problem, right?
Yeah, because when you do like that, you would turn the antenna towards the nearest cell tower, which now will be way beyond our heads. So that will not really work. So there's a lot of interesting topics to be handled here. Finally, I would also like to talk about this switching, because these satellites, they also need to be switched in between. And you're used to, from the satellite communication, to have tracking antennas that always follow the satellites, but that won't work in a simple smartphone device. So we need to adopt a completely new set of concepts which need to be glued together to make it work. And finally, there is this interconnection between the infrastructure components of the network. On the TN side, they have cable, they have fiber, they have even radio towers to sort of handle all of that. In the orbit part or the satellite part, we do have the inter-satellite linking as a coming up option, and it's also being dramatically improved over the years with light and lasers and whatever. So we believe that we will see a future where we have a near real-time opportunity with also polar coverage from a non-geostationary satellite service constellations. Yeah. And so I also have sort of what comes into the user groups, as we did talk about. You mentioned Iris Squared. That's going to be a combined government, combined defense, but also a commercial system. This will most likely make it part of critical infrastructure, and there will be some national security going in to support all of that, which also now have to be shared between states, which will also be an interesting perspective. Government and defense has until now been really heavy users of satellite communication. They are starting to show interest in standardized NTN solutions. I think I have also heard it from them that what they're really after is the off-the-shelf technology, which is more mature and cheaper also for their applications.
Cool. Thanks, Sven. Before we just skip to the next slides, I just want to address one question that we have from Marco, who has actually asked a very relevant question, whether or not you are talking about GEO or LEO satellite, or do we call multi-orbit constellation? What is your perspective, and how do you see this in relation to 5G New Radio?
GEO satellites has the clear advantage that they are sort of fixed, and they have lots of power, high gain antennas, and they are there. That's a big advantage. LEO satellites or non-geostationary satellites are still to be built. On the other hand, they are very much closer to the surface of Earth, so they have other advantages. So when we are talking about satellite or NTN, we are not talking of any particular orbit. We are talking about satellites in general, and all of it is capable to run the NTN services that we are addressing.
Okay, thanks for that.
And I do believe in a hybrid solution where we have LEO satellites, MEO satellites, GEO satellites, or even flying drones as part of the communication infrastructure.
Yeah, different challenges, but the feedback that we are getting across the satellite industry is that this is going to be a multiple orbit solution, right? Yeah. Cool. So, Base, let's get back to the next slide, and I can see there's already coming questions in. Keep the question coming. We will get back to most of them later in just a minute or two. Yeah. But Sven, based on your experience, what are the next steps, and what are the opportunities going forward?
We, as an industry, need to accept the fact that it's one thing to develop technology. I'm an engineer, so I know what I'm talking about, but it's a completely different thing to make it work in real life, to have it matured. And the maturing comes from use, from real use, and we ultimately need to have devices and service offerings out in the field for being used by the market. Then, of course, the integration between TN and NTN is crucial. As we talked about, there are heavy users already having a solution on the existing satellite communication. But the rest of us, the so-called occasional users, they will need to have this integration managed well before it's taken in. And then we have talked about it before. User experience is key. I have one example which I would like to bring up here. It was told to me by a satellite operator some years ago. He said that he had a backpacker somewhere in the outskirts that would like to have connectivity everywhere. So he invested in a device, and then he put it in his backpack, and he did not understand why it was not really serviceable. That's a good example. Of course, you cannot get service from the inside of a backpack to a smartphone, for instance. That's obvious for me, but not obvious for the users. Yeah.
Cool. And
standardization.
Yes.
It's quite easy. Interoperability, this opportunity of a huge ecosystem of suppliers. That's the upside. The downside is we do have to make some compromises, and we will not be able to make technical solutions that are equally good for all the use cases. So we need to accept that what we bring will serve a lot of different use cases and thereby have the large footprint we need. And finally, that's a question I did not find myself. I don't like talking about timelines. No, but one thing is for sure, the request will drive the timeline. Whether it will be the NTN services as a business in itself that will do the work, or what I believe will be the NTN extension of TN will be setting the pace for new radio. I know you're going to ask me.
Yeah.
I don't think we will see it until late 26 in real life.
In real life. And I believe that maybe the R Square project where we will see it the first time.
Yeah.
But let's get back to that on another webinar, right? And with this now, we are getting to the part of the webinar where we are going to open up for all of your questions. And as I mentioned before, we have some questions, and so maybe you can help me with the program. Yeah, where do I see all the questions?
I think just Q&A. I think it's okay.
It's okay there. Okay.
Yeah. So we have a question on how to maximize return of investment by deploying release 17 that may mainly support narrowband IoT and quite less profit. New radio is in fact part of release 17, so it is possible, however, only supporting transparent mode right now. If your use case will be achievable via transparent mode, meaning that you have either a very good link budget from a geostationary satellite, or you have a limited geographical area, then this could be, this is doable. So we are seeing calculations being done. We are doing so-called feasibility studies as part of our portfolio, where we are helping operators calculate what can be the upside of an investment. Yeah, we have talked about LEO versus GEO satellites. Then it says, what is the technical difference in terminal device comply with 3GPP release 17 between working with LEO satellites and GEO satellites? Is the difference only antenna performance? Seen from a conformance perspective, all devices are equal, whether LEO or GEO. And we believe that the main difference will be the throughput you expect. The more throughput you expect, the more you would need to have high gain antennas. So for the small amount of data we talked about earlier, going down to 1, 2, perhaps 3 megabit per second, that's achievable on an internal antenna. We have been joking a little bit about, when I started in mobile phone business, we had retractable antennas to sort of cope with the poor link budget. That might come back, but who knows?
Maybe, yeah, and that will maybe give us the indoor coverage that you were saying before. I don't know. No, I'm just kidding.
Right. But we also do see that there's a strong interest for the existing VSAT technology to adopt 5G New Radio. So there we have suddenly the high gain antennas, so that can solve the link budget issue.
Yes, and they can kind of like, like buy standardized products and buying into this future ecosystem of existing technology, which is great. Okay, we have a question related to whether or not you guys can buy a neatly packed 5G New Radio base station software stack from us. The simple question is no, you cannot. To be honest, we're just starting the journey. We have done a lot of studies so far. We have started the initial phase of the development,
and we are joining the standardization.
Exactly. So we're joining and following the standardization, and knowing that we might be into release 18, maybe release 19 before we get like a rock steady product. So that there will still be a couple of years or so before we are able to bring a product to the market. So sorry.
But of course, we are more than happy to have bilateral discussions with any of you about what we can offer.
Yeah, and that's one of the focus areas of these webinars that we are holding, is kind of like reaching out to the industry and getting these dialogue. You and I spend a lot of time talking to the different actors in the industry, and any one of you are more than welcome to reach out to either me or Sven for further discussion offline and away from this webinar.
Yeah.
I think there's one more.
Which parts of the 5G NTN Node B do you think are suitable in the future to run directly on satellite? That's also one of the very good questions. As I said, we have seen suggestions where you are only bringing the radio units, so the really hardware part, to the satellite, but we are also seeing concepts where even the complete radio access network, but also parts of the core network are installed at a satellite. And the big difference is whether you want to have autonomy into space. So with the radio access network and parts of the core network in space, you will be able to do distributed data switching. So the data from one terminal do not have to come to ground to be switched to another terminal. So that's one of the advantages, but it comes with a price. Of course it does. Yeah. Then there's a question on how much gain do we really need for a satellite. To be absolutely, honestly blunt here, I can't answer that question, but I will be happy to make sure that it's answered afterwards, which goes for all the questions that have been posted here. We will answer them offline, and they can be available afterwards on our webpage, and we will send a link to these answers from ourselves to all of you who are attending today.
Okay. In respect of the time, Sven, let's just take the last question and maybe like just short answers. So why is interlinked satellite so important?
It's important because if you have a non-geostationary constellation, it's not possible to reach everywhere a ground connection. So this is done just like on the ground by connecting the individual nodes in the network by this case inter-satellite linking. With that, you'll be able to do even video conferencing. You'll be able to do speech calls, voice over IP from the polar region to somewhere in Africa. So basically this is what's opening up. So a connection in between the individual components of the network.
Okay.
In orbit.
Thank you, Sven. So to summarize some of what we think are the key points of today's webinar, besides some of the technical details that you have been so kind to share with us. By unifying non-terrestrial and terrestrial technology, the barriers between the different satellite systems will be eliminated, allowing the end user to roam freely between terrestrial and non-terrestrial networks of different operators. That's one of the key elements. We also know that just as 5G technology in an NTN network needs to evolve from its current rollout state, and we have one who's already wants to buy our product, but we have to remember that the same goes for 5G in a non-terrestrial network. It will follow its own evolutionary path into the complete integration. And 5G New Radio standardization is by far the most promising opportunity to create new business models involving both the terrestrial and the non-terrestrial communication industry. Yes, and with that, let's say thank you for attending today's webinar.
Yeah, thank you for hosting us.
And we hope to see you again on the next webinar. So thank you and goodbye.